All right, in this example, we're told that a man starts 50 miles away from his home and takes a trip in his car. He moves in a straight line, and his home lies on this line. His velocity is given in this graph. All right, so let's take a look at this graph. Now, we're given a frame of reference. Our reference is his home, right? And we've got a positive direction and a negative direction. So we're assuming that positive is toward home and negative is away from home. Now, it would be helpful to have a t-axis on here. So I'm going to draw in a t-axis here. I think there's supposed to be one there, and you can see, let's take a look at what's happening over time. We can see the velocity is changing over time. And so the question is, when is the man closest to home, and approximately how far away is he then? All right, so we know that if we integrate velocity, we get the total change in displacement, right? And so here we have positive velocity, and this distance is positive, meaning that he's moving toward home. Okay, now we have to sort of estimate here that we can't actually evaluate this integral directly, but we can estimate the area under the curve. And so I can look at each grid. Each grid is 1 by 30. So each rectangle represents 30 miles, right? Because it's 1 unit wide and 30 units high. So 1 hour wide and 30 miles per hour wide. Multiply 30 miles per hour times 1 hour, we get 30 miles. Okay, so that's how we're going to estimate the area. So if I look at this first section from 0 to 2, this is t equals 2. Each one of these, the area under this curve, we basically got an area. It's about half of a rectangle in area. So I'm going to estimate this area to be 30 miles. Okay, so he's moved 30 miles toward home in this first 2 hours. Okay, now so at t equals 2, he's traveled a total of 30, and that 30 miles is toward home, so it's in the positive direction. So I'm going to put a little positive sign here. Now we want to know how far is he from home, right? So that's going to be essentially the closest he gets to home, because then down here he's moving away from home again. So we want to know how far is he from home. So we have to look at where he started out. He started 50 miles away from home, right? So essentially he started out at a negative 50 miles, and he moved 30 miles closer to home. So at this point he's still 20 miles away from home. Okay, and so it's negative, meaning that it's away from home. All right, so the next question is asking, when is the man farthest from his home, and how far away is he then? Okay, so at t equals 2, he's 20 miles away from his home, and then you can see all of this area down here is negative, meaning he's moving away from home here. And so what we can do is just approximate what this area is. Again, just by looking at the rectangles. Okay, each one represents 30 miles. And so if I estimate here, there's 30, 60, 90, maybe about 100 miles. I'm going to say it's 100 miles, but it's a negative 100 miles because he's moving away from home. So if he started 50 miles away from home, and then he traveled 30 miles toward home, and then he's 20 miles, right? At that point, at t equals 2, he's 20 miles away from home. Okay, so that's a negative 20 miles. Okay, and then he's moving 100 miles further from home, right? Because again, this area is negative. Oops, miles. Okay, so we have a total of negative 120 miles. And because it's negative, and we've taken our frame of reference to, we've taken the frame of reference to mean that negative means away from home. So he's 120 miles away from home. Away from home at t equals 5. And so that's the farthest he is, at least given the information that we have from this graph. That's the farthest he is away from home. All right, well, that's all of the examples I have for this lecture, and I'll meet you in class.